Well, folks, let's get to the part C of the problem. And here in part C, suppose if you decide to go ahead and then conduct the research, engage this research firm, and what would they come back and tell you? They would come back and tell you whether their prediction is about state of nature S1 or they would predict the state of nature S2. So let us say economy being good or economy being bad. That's what they would do. But so when they come back, when they tell you, this is the information that they will provide to you. See, when they are conducting the survey, the research, so the underlying current is there. So that means the state of nature is prevailing there, either S1 or S2. One of these two state of nature is prevailing. What would they do? They would ask, maybe let's say some people to say, whether could they say, let us say S1 is good economy, S2 is bad economy. Okay. Let us say the good economy is going on right now. Let's say when they do the survey, when they ask people, some of them may say, yes, the economy is good. Okay, and some of them may say economy is bad because who knows, maybe particularly they are experiencing that. In other words, this is what they actually measure. This is what actually they measure. Actually, the economy could be good and the prediction from the survey may come out to be good. That's about 60% chance. The economy could be good, but their prediction may end up as being economy being bad. Okay, why? Because it's a survey of a small group, not the entire population. That is why there is always a chance that even in good times, the bad outcomes may happen. Okay, so that probability is about 40%. Okay, on the other hand, let's say the actual prevailing nature, state of nature, when they conducted the survey is S2. Let's say economy bad. Well, maybe there could be some sector that we're doing good, and if they happen to collect the information from that sector, they would say, yes, economy is good. So that's about 20% chance, and of course, we do expect that to be a low number, not a high number. Okay, now the economy could be bad, and of course, the survey that they do might come back as being bad. Okay, so those chances should be higher. That's 80%. This is what they actually measure. Okay, this is what they measure. So they will come back and they will tell you the probability of predicting S1 given both conditions. Okay, economy being good and bad. So that's what they will come back and tell you as 36%. And when we go through the calculation, we will get that for the S2 as 0.64. Okay, from this, what actually we have to use in our analysis is just the opposite of this. That's why I have them side by side here. So when the survey company comes back and tells us, yes, the economy is going to be good, okay, that's their prediction, what is the probability that actually it is going to be a good economy? Okay, so again, their survey, their research is based on a small sample, and we are trying to generalize that to a larger sample. Okay, so that happens to be about 0.667. Now, if you go back to the prior probability for actual outcome was 0.6, now when we engage the research firm, when the prediction is that of a good economy, naturally the probability of this should be higher than the 0.6 that was our prior probability that we had. Okay, and likewise, even when the prediction is a bad prediction, there is a chance that the economy may turn out to be good, which is about only 25% chances, and we expect this to be a lower number. On the other hand, if the survey predicts a bad economy, and actually the economy is going to be bad, has to be a higher 75, and in our earlier case, we thought it to be only 20%. Okay, only 20%. Okay, and actually as to being 0.6, that's 60%. Now it has to be 0.75. Actual S1 is 0.4. Now once the survey comes back with a positive prediction, that should be better than 0.4, that is 0.667. So this is what we want to use from what is given from the research company is this, and we know from our previous experiences this is what the prior probabilities have been of these two states of nature. We had to use this information and this information to get to this information. So that is what the Bayes theorem gives us, and these are the algebraic steps that you proceed through. So the first step is probability of finding a joint probability. That means the given state and also the finding. Let's say economy good and the survey results is good. That is what the joint probability is. So that is the product of the probability of the state and the probability of finding given that is the state. That's what here. That is probability of state being S1. Let's say that is, okay, the economy is good. That is 0.4. Probability of finding that state given the state. That is predicting the survey result to be S1, good economy, given actually the economy underlying is a good. That's 0.6. That is that one. So likewise, similarly for the other three combinations, you get that. Okay. So now, when we conduct this research, so the prediction of getting an S1, that is a good economy, does exist from both situations. Actually it is good, actually it is bad. So that is these two terms. So the total is 0.36, and that of course the S2, bad economy, for example, should be 0.64. Together one of the two states should occur, so that's why we have totally 1. Now we take this information and that information, go back and we find what we need to use in our analysis. Okay, is the probability of actually the economy is going to be good given the survey that we got from the research company did predict the economy to be good. Okay, so that's only 0.667, which is nothing but the 0.24 times the survey being positive is that 0.36. That's that one. Similarly, the other figures. Okay, now when you go through these algebraic calculations, it is kind of messy and confusing. So the best is to kind of use this information that we have here. Let me keep these two same here. So this is what actually we measure there in the market. Okay, probability revisions given the prediction is S1. Okay, let's say the survey company comes back and tells us it's going to be an S1, that is good economy. So the outcome is actually the economy is good. Here actually the economy is bad. So this is a conditional probability. That is the prediction. That is the prediction that we have here. Prediction that the economy is going to be good given actually the economy could be good, the economy could be bad also. So that is 0.6 and 0.2. That's what the company is going to give us, 0.6 and 0.2. The prior probability that we know from historical experience of actual S1, good economy, bad economy, being 0.4 and 0.6, the joint probability is the product of these two. 0.6 times 0.4, that is 0.24. Okay, that is what you see there. Okay, when you click it. And this being 0.2 times 0.6, that is that economy, joint probability being 0.12. So the total is nothing but the sum of these two. Okay, sum of those two. Now the revised probability, that's what we actually had to use it in our analysis. That is this part here. Okay, which is nothing but the ratio of this 0.24 to 0.36. And this is 0.2 to 0.36. That's what here. See, this way, using this sort of tables makes it a lot more easier than to go through the algebraic manipulation. Similarly, given the survey prediction being bad economy, we have same numbers. Now they will come back and tell us 0.8 and 0.4. We got 0.4. That is actually it is S1 prediction is S2. Actually, S1 prediction S2 is 0.4, and actually it is S2 bad economy, and also prediction is about the bad economy is 0.8. Prior, take the product of those two, similarly before, joint probability, and sum them up. That's the probability of predicting a bad economy. That's 0.64, and it's the individual ratios is what you see here. That's the revised probabilities. So this is what we need to. Okay, part G of the problem is, suppose if the survey result comes back and tells you, okay, it's going to be a good economy. It's very similar to what we did before. You take the product of, replace those 0.4 and 0.6 that we had with these new probabilities and compute the expected payoff. Go with the best one, that is 233.4. And similarly with the bad one, bad economy predicted. Again, just change the probability figures from 0.4 and 0.6 to what we just computed, these two, okay, and use them, and the expected payoff is highest there, so go with A2. Okay, what is the expected payoff given the research? In other words, about 36% of the times they will predict S1, about 64% of the times they predict S2. So the average is nothing but the weighted by the payoff and the probability 0.36, and here it is 75 and the probability of 0.64. So that's what we have here, 0.36 times 233.4 plus 0.64 times 0.75, and that is the expected payoff given the research, but it's going to cost us $100 to do the research. So you are better off, with this one by $32.02. Okay, so what is the efficiency of this survey then? This efficiency of this survey is equal to, we are able to get only $32.02 out of, if you go back to the expected value of perfect information, it was 120. Okay, it was 120. So that is divided by 120, and that if you do it, that is 32.02 divided by 120. It's only about 27% is the efficiency of the survey here. Now, do you want to go with this firm? So this could be a method we can use to determine which research company is better. So the optimal policy then is not to do any research but simply choose A1. Why? Because we would make 232. Okay, we would make this 232, not 232, we would make this actually just this 0.36 times 233.4 plus 0.64 times 75, that sum is 132. You take out the $100 that you had to do, that you had to give for research, that's 32.02. So actually, if you look at it, you make only $32.02 by going through the research. But if you don't do the research, going back to this base rule, our decision is to kind of stick with A1, and the long run average is $100. So we are $100 is what we have here. If you go through the research firm, the long run average is only 32. So we are about $68 less. So there is no point to go with the research firm and to proceed with our decision based on our analysis, whether that is to choose A1 all the time.